Section 2.4, Reasoning in Algebra. To discuss algebra in geometry, we need to discuss the properties of equality. You used these properties through your algebra class. And now what we want to do is actually define them more clearly when we go through an algebraic proof relating to geometry. Here we have the addition property. And you remember that as just adding the same thing to both sides. And when I do that, the left side and the right side are still equal. Therefore, the subtraction property would be subtracting the same quantity from both sides. The multiplication property would be multiplying the same quantity to both sides. And the division property would be dividing the same quantity on both sides. When this occurs, the left side of the equation is still going to equal the right side of the equation. Or, as your teacher probably said, what I do to the left, I do to the right, and it all works out. We also have properties of equality known as reflexive, symmetric, and transitive. I label these as 1, 2, and 3. Notice in the reflexive property, it's a mirror image of itself. A equals A, and this is very important in geometry. For example, if I gave a triangle and I called the top point A, that point A is inside the little triangle and also inside the big triangle. Therefore, angle A is equal to angle A, and that is by the reflexive property. And notice the way I kind of make people understand this is, number one, because there's one equal sign. Symmetric property is if I have A equals B, then B equals A. Notice there's two equal signs, therefore that's why I label this 2. And a lot of times we use this because when we set up any algebra problem and I end up with 1 equals x, then you see them write it as x equals 1. And that is used because of the symmetric property. The transitive property, I think you can see why I labeled that 3, because I have 3 equal signs. This is very similar to our syllogism property that we just defined in our last section. If A equals B, would be like PQ, QR, then PR. This is just based on the properties of equality. The substitution property is just replacing elements that are equal. For example, if A equals B, then B can replace A in any part of my expression. Here we have the distributive property of algebra. Recall, I have A times the quantity of B plus C. I just take A times B, and I get AB, and A times C, and I get AC, and I just bring over the plus sign. That is the distributive property. Properties of congruence. They are the same for the properties of equality, except in this instance, we're dealing with congruence rather than equality. And in geometry, we know congruence relates to equal measure. Segments have equal measure, then the segments are congruent. Angles have equal measure, the angles are congruent. Again, a way to help remember reflexive, symmetric, is transitive is the number of equal signs, which is 1, 2, 3. Equal signs, reflexive, recall, has 1, symmetric is 2, transitive is 3. But we still need to apply the properties related to these. This is just a way to help remember those properties. Our first example is an algebraic equation. They want us to give the reasons for each step. Here we have an equation, and that is our given information. We want to know what property takes us from our given to the next step. And if we multiply through this parenthesis with 3, that would be the distributive property. Therefore, when I multiply by 3, 3 times 2/3 is 2x, 3 times a negative 4 is a negative 12, and bring down the minus 5. Then what allows us to go to the next step? What they did here is add 12 to both sides. That is the addition property of equality. To get to the next step, they divided by 2. Therefore, to get the answer x equals 7 over 2, they finalized with the division property of equality. This is something that you have done through algebra. Now what we're doing is just labeling the reason why we're allowed to do that. And that is the properties that were on the previous slides. On my next example, they want me to fill in the reasons that justify each step. I'm given angle ABC, and in the interior of that angle, I have ray BD. They want me to solve for x, and I'm given that ray BA is perpendicular to ray BC. Therefore, I know at some point inside my equation, I'm going to be able to substitute for the measure of angle ABC 90 degrees, because I know from the definition of perpendicularity that two lines that are perpendicular form right angles, and right angles are 90 degrees. Our first step, I have that the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. In other words, the two smaller angles are going to make up this right angle. This is because of the angle addition postulate, and that was taught on previous sections. Now what we have is the measure of ABD is 2x. That's from the diagram. And the measure of angle DBC is 3x plus 5. And I know that the measure of angle ABC is 90 from the given information. And that is substitution. Now we're going to proceed through the problem just like an algebraic equation. Therefore, what I'm going to do is combine like terms, and in place of these two elements, I'm going to put in 5x plus 5 in a combined like terms. But we're going to call that substitution. To go from step 3 to step 4, they subtracted 5 on both sides. That's the subtraction property of equality. And to go from step 4 to step 5, they divided by 5 on both sides and got x equal to 17. And that would be the division property. In this example, I'm given that segment CB is the segment bisector of AE. And what I want to do is give a reason to justify each step in the proof. Step 1 is C is the midpoint of AE. From the given information, I know that a segment bisector intersects a segment at its midpoint. Therefore, this is the definition of a segment bisector. Step 2, segment AC is congruent to segment CE. That's because of the definition of a midpoint. That's the point that divides the segment into two congruent segments. I know that the measure of AC is given to be x plus 5, and the measure of CE is to be 3x plus 3. Therefore, from step 2 to step 3, they just replaced those values. That is substitution. Now we have an algebraic expression that we need to solve. Here, they subtracted x on both sides. So step 4 is the subtraction property. From step 4 to step 5, they subtracted 3 on both sides. Again, the subtraction property. From step 5 to step 6, they divided by 2 on both sides and got an answer of 6 equals x. That's the division property. And from step 6 to 7, they changed from 6 equal to x equal to 6, and that's because of the symmetric property. On this slide, they want to use the given property to complete each statement. Number 1, the symmetric property of equality. I'm given if the measure of angle H equals the measure of angle J, using the symmetric property, I just switch those values. So I have the measure of angle J is equal to the measure of angle H. Number 2, substitution. Here, if HK equals 12, and I have the equation HK plus FD equals CE, then I'm just going to use substitution. In place of HK, I'm going to substitute 12 plus FD equals CE. Number 3, reflexive property of congruence. Segment DF is congruent to segment DF.